we know what a random variable is, so let's start with chapter 6, and let's talk about what I like to abbreviate by RV, random variable. We normally like to denote them by uppercase X, uppercase Y, etc. If you remember, we did talk about one random variable, but I didn't tell you that it was a random variable, which was Z, which is the Z scores. But it's not a discrete, so we're not going to talk about it today. It will come back when we get to talking about continuous random variables. So let's talk about continuous. See, I talk too much. Discrete random variables. What are they? They come from, where's my prop? My props are gone. So, what is a random variable that is discrete? As an example, I didn't give the definition yet, but let me just give examples of discrete. So, discrete random variables right here at the top. So, for example, number of cars driving on a road. The number of cars is a variable that is discrete, like X. Another one, let's say Y, number of kids per family. These are discrete random variables. So, in general, what is a random variable? It's a numerical measure of an outcome. So, a random variable, numerical measure of an outcome. Like this, the number of cars driving on a road, 10, 15, 20, I don't know, per hour. Normally, they appear from a probability experiment. Because they all come with probabilities. So every random variable comes with probabilities. We will be able to determine the probability of an outcome in a minute. Okay, now, because these are natural numbers, right? You can even include 0 or 1 or 2 or 3, 0 kids, 1, 2, 3, etc., etc. These are discrete. Let me just give you, so we have an example here of continuous random variables, or random variable, time. To the next car passing. That's an example. We already talked about the weight of an airplane. Flying out of a particular airport, flying out of, let's say, LA airport. So discrete, fixed, continuous, it can be anything, right? The weight can be anything. It can be, it's a continuous variable, continuous. Okay, coming back. So you have some examples here that I already put in. The number of light bulbs that burned out in a factory, that's a fixed number. The length of time between phone calls, that's another continuous variable, random variable. Okay, so a discrete probability distribution, what is it? So let's say now, we know we have a random variable. So random variable X. And X is a discrete random variable because it's the number of movies streamed on a TV channel per month. And we do have the distribution. We're going to put it in StatCrunch in a minute. So we have x and the probability of that outcome. Notice that this is lowercase x. These are the possible outcomes, 0, 1, 2, 3, 4, or 5. These are outcomes. Or if you want possible outcomes, lowercase x. This is the random variable, uppercase x, that represents the number of movies such and such. Now, the probability for each outcome, the probability for 0 is 0.06 or 6%. The probability for 1 is 0.58, the probability, and so on and so forth. 0.22, 0.1, 0.03, and the last one, 0.01. What makes this a probability distribution? What makes this a probability distribution? And is it a probability distribution? Well, we have to go back to what we studied last time and say, as long as the sum of those probabilities of xi, each element, from I equals 1 to the last one, which is 6, as long as the sum is how much, and as long as the all probabilities for each outcome are between what and what, then I'll conclude yes. If any of these two conditions is not fulfilled, then I'll say no. It's not a probability distribution. So let's check the sum. I'm adding all the probabilities, and what should it be? What should it equal to? If it is a probability distribution, and then we have to check this.
1.
Yes. So 0.1, 0.03, and 0.01, it is 1. The sum of all these probabilities is 1. And I see very clearly that all the numbers are between 0 and 1. Because both conditions are fulfilled, I would say yes. It's a probability distribution. Both conditions are fulfilled. So now in StatCrunch, allow me a second to show you. So I would like us, I will show you if I share my screen, right? Otherwise, how will I show you? Okay, so in the variable at the top in the first column, just write X or number of movies. Where is my keyboard? So number of movies. You can see what I'm doing. I already entered my data, so I'm not going to use this. And then this, the probability. I would write it like this, as P of X. So I know what it is. This is what I recommend. You do whatever you want. I had a few minutes and I did enter my data. And let me know when you have it. I called it Discrete RV1. So I entered my data and I called it whatever. I said Discrete RV1. You can call it the way you like. And our first example here on the handout, it's asking us to create the probability histogram, to take a look at the probability histogram. So let's do this. Let's go to Stat, Calculators, and go scroll down to, I can't see it. Why I can't see it? Let me move this out of the way. Custom. We're going to select the variable x. I denoted it by x. You denote it by whatever you want, but I think x will be the best. P of x. And then click on compute. Does everyone have the data? Sorry, I should have asked that. Do you have the data? Okay. So just click on compute. And let's take a look. Remember, this is discrete distribution. So at 0, this height, this probability, so at 1, this probability, at 2, 3, 4, and 5. Where do you think, because eventually we will calculate the mean of such a random variable, where do you think the mean will be, or where, close to what? And you see it, it already calculated it for us. And why will it be close to 1? Either on the left or on the right. In this case, on the right. Why? Because that's where the majority, the highest probability is. So it will be concentrated in this area. So this is the probability histogram for example 1. Now, what I wanted to show you here is that we can also determine other types of probabilities. For example, let's suppose I would like to determine the probability that x is less than or equal to 1. What will this do? It will add the probability for 2 to the probability for 1, and this is what we have, 0.64.
Excuse me, my stat crunch just stopped working. I'm having the same problem that other people were having. It says my temporary access to this course expired.
Which means we have to talk after class, but if it expired, have you ever paid for it?
I never paid for it. I just signed in with
Yeah, you have to pay for it. There is no other way.
Okay.
Yes, one student had paid, and we managed to solve the problem right away, but the other student has to pay like you do. So I'm so sorry. And we can talk after class.
Okay.
Thank you.
Did you get like a code on your book sheet? Like if you got other books, did you get like a pin or whatever on the sheet?
No, I didn't see one.
Oh, okay.
Okay.
Sorry.
No problem. Thank you.
I'll stay after class so we can figure it out.
Yes. So thank you for your help. So let's suppose now, because these questions will pop up, let's suppose now I would like to determine, I can do it by hand, but let's suppose I would like to determine and the probability that the random variable is greater than, let's say, 2. Without 2, what will you add up? You will not add up 2, but you will add up 0.1 to 0.03 and to 0.01. And we already know that the answer is 0.14. So I'm asking the computer to, the software to compute, and I expect 0.14. Here it is. And it even shows you what it added. See, they are in red. So it added 3, 4, 5. Now if I say greater than or equal to, it will mandatory add 2, 3, 4, and 5. So we knew it would include, we had initially 0.14, and 0.14 plus 0.22 is 0.36. What if I want to say less than or equal to, and I put 5? Before I put 5, what do you think the software will give us? What would be the probability? If I put 5 instead of 2, I don't want to put it yet. Less than or equal to 5, what will the answer be? It has to be everything. It has to be everything because we don't have anything above 5. So the probability of a sure event, that's 1. What if I put less than or equal to -2? What do you think the answer would be? It should scream at me. 0. It's not possible. There is nothing. Okay, this is for the standard. But what about in between or between? Okay, this time it's asking, or we can calculate the probabilities between this and this. So I'm going to put between x equals 2 and x equals 4, including. So we will add 0.22 to 0.1 and to 0.03. So it will be 0.3, 0.35. 0.35. And it even shows it added the probability for 2 to the probability for 3 to the probability for 4. They are in red. Any questions? Okay, what can you say about this distribution? Is it bell-shaped? Is it skewed to the left? Is it skewed to the right? Could you say anything about it?
I believe it's skewed to the right or left.
To the right, where the tail is longer. Yes, very good.
Okay, to the right.
Perfect. Okay, now let's move on. I'm going to stop sharing for a moment. I'll come back to this. Okay, moving on to, let me take the keyboard out of the way. So now, this is a random variable. We were able to determine the probability histogram. We realized that it appears to be slightly skewed to the right. Now, we would like to determine for this random variable the mean, the variance, and the standard deviation. So, compute mean, variance, standard deviation. Okay, so in order to determine the mean, this is the expected value. Same thing. Or mean. Or just mu for x, because we may have more than one variable. So the mu for x is the sum from I equals 1 to the last x of the product of each outcome. This is lowercase x multiplied by the probability of each outcome, lowercase x. Okay, so for our example, we already saw it because StatCrunch gives us everything. But how do I determine the mu for this variable? Will be 0 multiplied by its probability, 0.06, plus 1 multiplied by its probability, 0.58, plus 3 dots, and I continue with the last one, 5, the outcome for 5 movies, multiplied by its probability. And of course, we expect a probability, an expected value of 1.4. So let's also do this with the graphing calculator. So let's